Hello, students. Digital electronics is a branch of electronics which deals with digital signals and systems. All of us are well aware of impact of modern computers, laptops, internets, smartphones, smart TVs on our society. The advent of ICs, that is integrated circuits, hence digital electronics is what responsible for it. All new technical revolutions that you see around, that are in robotics, artificial intelligence, and automations, all of these are responsible only because of advents in, that is, new inventions made in integrated circuits, and that too because of digital electronics. So study of digital electronics is very essential for all technical background students. So therefore, what we are going to study in this and forthcoming chapters is about operations of these smart devices and smart systems that are based on principles of digital systems. These digital systems accept digital signal as an input and processes that signal and gives you output in the form of digital signal only. That means it will have either high or low as an input signal and high and low as an output signal. There won't be any intermediate stages between high and low or low and high. Either signal will be directly low or signal stage will be directly high. But our world is not like that. Our surroundings are made up of different signals which will have different various stages and continuous values. Those signal we called it as a analog signals. So therefore, we need to develop a system which will be able to interact with the outside world, which is made up of analog signals, process those analog to digital, and then gives the output in the form of digital then to analog. So therefore, digital electronics or branch of digital electronics is obviously responsible for that case also. So therefore, to study and understand all those technical different things in our syllabus, we have introduced the subject digital electronics. So let us understand, before going towards or before diving in the ocean of digital electronics, first we need to identify what are the different signals that digital electronic devices needs to deal with. So those signals and their study, let us start in this particular chapter. The chapter's name is Analog and Digital Signals. And as you are well aware, I am starting with an example. Let us consider the example of a musical concert. Now, in this particular case, let us consider the musical concert of a singer, say, what Arjit Singh, right? So, Arjit Singh is going to sing a song in a musical concert, which is obviously witnessed and witnessed by large crowd. Say 10,000 people have gathered for this particular concert. Now, in this concert, to address and sing a song for 10,000 people, this large group, obviously, so you required microphone, that is, right, mic, short form is mic. So mic, through mic, Arjit Singh is going to sing a song, and we required, right, we required a speaker which will deliver the song which has been sung by Arjit Singh. So therefore, the two things that will be visible to any ordinary person which were present in that particular concert, the mic and speaker. The technical background of it, that is the curious minds like us, is going to identify what are the different signals that are involved in this process. You can see here the diagram. The song is in the form of analog signal which is captured by microphone. Then this analog signal, which is something like this, right, is a continuous signal. You can see this signal is marked on a graph of V in, that is voltage, and time axis, time is present on x axis. So V versus T is the graph which is going to show you this type of pattern. This is called as analog signal. This analog signal will be going as an input towards digital signal, but not directly. This passes through ADC, block of ADC, that is called as analog to digital conversion. As I already told you, our digital system is not capable of processing analog signals. It is capable of processing digital signals only. So therefore, analog signal has to be converted into digital form. So you require ADC. Full form is analog to digital converter, which converts the signal in this form that you can see. Now there will be discrete changes between high and low only. There won't be any continuous changes. So this is a digital signal which is processed by digital system. Digital system after processing creates a signal in this fashion only, but we want to send the signal to the speaker, which is capable of giving output as an analog signal. So therefore you required one particular box of converting digital signal into analog form, that is called as DAC, stands for digital to analog converter, which converts given digital signal, accepts that digital signal and convert into analog form like this. So therefore now this is the signal that will be given to the speaker, and the crowd is going to listen that signal as a song sung by Mr. Arjit Singh. So therefore this is the whole process of converting analog to digital and digital to analog is the process, or is the process which works behind all the modern electronic equipments, automatic equipments that we as a world interact with. So therefore, to understand this, first we need to understand what is analog and digital signals. So let us study what is analog and digital signals. First of all, what is signal? Signal is an information converted to electrical form and suitable for transmission purpose. As we have seen in the previous example, information is a song or a signal which will be converted into electrical form and then which will be made suitable for transmission through the speaker to the output device. So therefore the output device, that is a speaker, acts as output device, is going to receive the signal which is nothing but converted into electrical form. So therefore any signal that we are going to understand is nothing but a electrical form signal. Now this electrical form signal is divided into two types, analog and a digital. So what is analog signal? You can see analog signal and digital signal both will be plotted on a graph which will be having y-axis as a value and time will be plotted on x-axis. So therefore you can see easily this is what the graph of analog signal, which is continuously changing, which will not have only discrete values. The highs and lows are different. So therefore this is what a graphical representation of analog signal. But whereas when you consider digital signal, you can easily differentiate that the digital signal will have only two discrete values. One is high and one is low. There won't be any intermediate values between high and low. So therefore that is called as digital signal. So both graphs obviously will tell you the differences, basic differences between analog and digital signal. We'll elaborate those differences a little bit more. As we have already seen that analog signal is a continuous one shown in the graph, and digital signal discrete, having discrete values like this. And these are the differences between the two. Analog signal will be continuous and digital signal will have discrete values. There won't be any values between 1, 0 or 1 and 2. There will be only discrete values. So therefore it's a discrete signal, whereas analog signal is a continuous signal. You can consider the example shown in the graph. So normally analog signals are represented by sine waves, whereas digital signals are represented by obviously square waves. Examples are human voice, that right now I am talking to you is an example of analog signal in which while talking I am changing my pitch from high to low, and also in between high and low also. Similarly, I am increasing the speed and decreasing the speed also. So human voice, natural sound that is coming out of anything that is around you, or analog electronic devices which we were using earlier, that is radio, old radios or old TVs in which the CRT tube was present. All those were analog electronic devices. Whereas in the digital case, the modern all devices are digital devices, that is computers, optical drivers, and so many other electronic devices, your mobile on which you are basically watching this particular video. All these are examples of digital devices. Analog devices or analog signal is a continuous range of values. You can see in the diagram also, its graph represents that it will have continuous values. The values represented on y-axis are continuous, they are not discrete. You'll realize that it's a curve represented by analog signal, whereas in the case of digital signal converts into it's a discontinuous values. You can see that it will have either high or low directly. There won't be any intermediate value which are present between a high and a low. The signal directly changes its state from high to low or low to high depending upon the situation. In the analog case, it records wave signals as they are. So analog signal is represented as it is with the help of graphical representation, that is value versus time. But in the case of digital world, you cannot enter the analog signal as it is in digital systems, because digital systems do not understand that. So therefore you need to convert that particular analog signal into binary waveform, and binary waveform means it will have only two types of states, either high or a low. So therefore directly analog or given signal cannot be entered into the digital system. You need to convert into binary waveform. In the case of analog, it can only be used in analog devices, whereas digital signals are suited for digital electronic devices such as computers, mobiles, and many more, and so many other devices that you are well aware about. So these are the main differences between analog signals and digital signals. So overall, we are going to study a lot about these type of signals. The signals which will be represented by square waves, which will look like this, in which the changes between highs and lows are very discrete. There won't be continuous changes. And the graphical representation of those signals will be represented by a graph in which y-axis will be plotting voltages and x-axis always plots time. So therefore this type of signal, not only this, but this type of digital signal we are going to study a lot. Now before studying that, first we need to understand that highs and lows are two discrete values, but only high signal when you consider, then it will represent the range of signals having voltages around that high mark. For example, if we consider 5 volts as a high voltage, then voltages around 5 volts like 4.9, 5.1, 5.2, 4.8, these voltages represented by a signal considered as a high. So therefore I have drawn this as a thick band of signal voltage levels which are representing high signal. So therefore voltage levels, not only single voltage as a high, but range of voltages which are considered as a high. Whereas low voltage range will be considered as a low voltage, where there will be some low voltages. Like for example, if I consider 0 volts as a low voltage, then the voltages around 0 mark, that is say 0.1, 0.2 or minus 0.1 or minus 0.2, these voltages will be considered as a low voltages in that specific signal, because due to some electronic configurations and due to some problems, it may happen that the considered high voltage, that is of 5 volt, may not be reached or may be over above it, it may be above the 5 volts, but still it will be considered as a high voltage or a low voltage. So therefore these two high voltages and low voltages are the ones which are responsible for creating a digital signal. Now let us see how. These high and low signal levels are nothing but called as binary digits 1 and 0 respectively. 1, that is high signal, and 0 representing low signal. The all other values between this high and low will be nothing. Only two types of levels will be present, high and low, and those two types of levels we called it as a binary digits 1 and 0. And these binary digits are called as bits. What they are called as? Bits. So binary digits are abbreviated as bits in digital electronics. So henceforth, whenever you encounter with the numbers 1 and 0, then understands that they are not ordinary numbers, they are representing voltage level high and voltage level low in digital signal. In the next lecture, we are going to elaborate more about the digital signals and its logic gates.